Hello, this is Mrs. Boffman, and it is so weird to be teaching and not have all your beautiful faces in front of me, but we're going to make the best of this next 2 weeks and potentially time after that, and we are going to make sure that we are staying healthy and active and safe. And if there is anything you need from here on out, just please make sure you're communicating with me, because I want to make sure y'all have the resources you need to keep up your AP stats and anything else. I just don't want y'all sitting at home doing nothing. So if you've been wondering about the AP test, some of y'all might have seen it, but I think they said March 20th they're going to release more information, but there's definitely going to be a way for y'all to take your AP test, so don't worry. All your hard work will definitely still pay off. But yes, if you need anything stats related or not stats related, please make sure you let me know, because I'm here for all of you. But we're going to jump right in. So if you have any questions at any point, feel free to either post them on Google Classroom or text me. The great thing I think about doing these videos will be that, because stats can get kind of repetitive with state plan do conclude, so you can pause if you need more time to think or process, or you can fast forward if you feel like you already knew that part, or so it kind of gives you freedom to go at your own pace. So I'm going to try to probably go extra slow and make sure I'm writing out everything, because no one can ask questions in the moment, so I don't want to confuse anybody, but you feel free to go at your own pace and use this video however most beneficial to you. So if you remember, before spring break we were doing chapter 7 and we were doing chi-square goodness of fit was the first type of chi-square test we learned, right? And so for that we had one categorical variable, and we were saying, did our sample seem to align with some claimed distribution? Here we did M&Ms, and you had your chi-square statistic, which kind of measures how far your observed is from your expected, right? So we did some chi-square goodness of fit tests, and now we're going to kind of switch gears a little bit. And what's different now is that you're going to be having a two-way table, so you have two categorical variables. That's the main difference between goodness of fit, is it's only one categorical variable. So we can fill in our blanks. I know you missed filling in blanks. It says, what if we want to compare distributions let me make sure it's straightened out so y'all aren't freaking out as you have to watch the video, of a single categorical variable across several different populations or treatments, right? So then first we have to display the data in a two-way table. So as soon as you see a two-way, I can't talk and write. As soon as you see a two-way table, you should know that you're not doing goodness of fit. So we have two different types of tests, though, that we use for two-way tables. The first one is a chi-square test for homogeneity. If you remember in class a long time ago, I said there's a word in this chapter that I can't always say, and that is the word. So if you watch another video and they say it different, they're probably correct and I'm probably wrong. Homogeneity is what I'm going with. So if you do a chi-square test for homogeneity, it determines whether the distribution of a categorical variable is the same across different populations or treatments. There's no difference. And then you have a chi-square test for independence, which we are not going to cover in this video. That will be Friday. Chi-square test for independence. And that's to determine whether there's convincing evidence of an association between two variables. But again, we're not going to focus on that. What we're going to focus on is the chi-square test for homogeneity. But before we really get into that, this video is going to kind of introduce an idea before we actually do the test using probability that we've learned before. So this lesson's going to be broken up into two different videos. So this is going to introduce the scenario. It says, market researchers suspect that background music may affect the mood and buying behavior of customers. One study in a European restaurant compared 3 randomly assigned treatments. There's no music, French accordion music, and Italian string music. Under each condition, the researchers recorded the number of customers who ordered French, Italian, and other entrees. Here's a table to summarize. And so what they ask you to do is calculate the conditional distribution in proportions of entrees ordered for each treatment. So this note is going to, before we do that, review some vocab. It says the researchers expect that music would influence customers' orders. So the type of music played, if whatever you're controlling or your treatment is your explanatory variable. This was chapter 3. So what you control is your explanatory variable, and then whatever you're measuring, which in this case would be what type of entrees ordered, is the response, right? They don't have control over that. So if you don't know how to set up your conditional probability, which we'll review what that is in a second, is you're going to compare the conditional probabilities of the response, always response variable, for the explanatory. Which another way you could say for is given the explanatory. So that given should tie back into that conditional probability. I have a formula chart. Hold on. So if you remember, our formula for conditional probability is the probability of A, that line means given B, is the probability of A and B over the probability of the given. So let's go and write that formula down for conditional probability. Conditional probability A given B equals the probability of A and B over the probability of B. So B is representing the given. So in this scenario, our given is the explanatory, which is the music. Right? So what if you want to kind of switch out A and B for what we're talking about, is we're going to do the probability of A, which is our response variable. So the probability of entree given, because the given should be explanatory, whatever music. So we're going to do that for every single one of these. What's the probability that they ordered French given no music? What's the probability they ordered French given French? French given Italian music? It's kind of confusing because they use the same words, French and Italian, but this is talking about music, this is talking about entree. So we're about to find a lot of probabilities, so I would suggest I'm going to set up a couple. Well, I'm going to do all of them because I have nothing else to do. But set up a couple with me, and then as you get it, I would pause the video, do the other ones yourself, and then you can see if we got the same ones and just fast forward. So do this with a method so you don't get lost. What I'm going to first do is all my French entrees and change my music. So I'm going to do the probability of French given no music. That would be this number. The probability of French given French music. And I'll do the probability of ordering French given Italian music. Oops. Okay, so French given no music. So what's the probability of ordering French and no music? Would be 30 out of the no music, right? It's out of the given. So no music, the total is 84. And that, if you get that as a decimal, would be 0.357. What's the probability of ordering French and listening to French music? It's 39. Given that it's French music, would be 75. which 39 divided by 75 would be 0.52. And now what's the probability of ordering French given Italian would be French and Italian is 30. Given Italian total is 84, which 30 divided by 84 is 0.357. Okay, so that's 3. Now we got to do the next 3 and then 3 more. So we got 9 total we should be setting up. Maybe I should use a different color. Okay, so now I'm going to do now I'm going to go to this next column. What's the probability of ordering Italian given no music? Maybe I should have kept writing music so you understand that this is entree, this is music. But look up here if you forget. The probability of ordering French given no music. Oh, nope, given French music. Wait. Why did I write that? That's why I was getting confused. I should have done the probability of ordering Italian given French music and the probability of ordering Italian given Italian music. Okay, so Italian none would be 11 out of the total none is 84. Italian French is 1 out of the total French is 75. And Italian was 19 out of the total Italian was 84. Right? Because that's Italian music. So you want to go to the total for Italian music. We did these 3. So notice we're using these totals because our given was music. Okay, if you get all those as decimals, 11 out of 84 is 0.131. 1 out of 75 would be 0.013. 19 out of 84 is 0.226. I'm running out of room. Okay, now we have our last row. So we have, I promise there's a point to this. Probability of ordering other entree given no music. Which maybe I should do the numbers as I go. 43 out of 84. The probability of ordering French given, what am I doing? See, it's confusing me too. Probably of ordering other given French music would be 35 out of 75. And the probability for ordering other given Italian music would be 35 out of 84. So if I get all these as decimals, 43 out of 84 is 0.512. 35 out of 75 is 0.467. And 35 out of 84 is 0.417. I feel like I kind of did that in a weird order. And hopefully you did that on your own, and then you just re-picked up the video right here and saw that we got the same numbers. Okay, and you don't have to go in the same order as me necessarily. So why did we do all that? We're trying to kind of go back to this idea is the distribution the same for each treatment? So we're going to kind of compare all these probabilities and see did the proportion change when we changed the treatment. So if you go to the next page, because that's kind of hard to compare, so that's why we have graphs, right? Make an appropriate graph for comparing the conditional distributions in part A that you just came up with. I'm trying to think if we should have done it the opposite. We'll stick with how we did it, since I already color-coded it this way. So we're going to put ordering French food on one graph, ordering Italian food on one graph, and ordering others. We're going to set up 3 different bar charts, right? This is, what type of variable is this? It's categorical. So the only type of graph you can make for categorical is a bar chart. Technically a pie chart, but we don't really use those. So let me try to stay color coded. I used purple for French food. So I'm going to say French entree. I'm going to have a bar graph. And then I'm going to have Italian entree. I'm just titling and drawing before I confuse myself again. And then I have other entree. And hopefully if we put it on a graph we can kind of see, is there some type of pattern or is it the same? And that looks really messy. Oh well. Okay. So then we have, for French entree, we had 3 different proportions, right? Based on the music. So on the x-axis, I'm going to put what music they played. So they either played French, Italian, or none, right? So what was this? So let's kind of look at our numbers. You know, they should really all be scaled the same so we can see. So the highest proportion was 0.52, it looks like. And it's got as low as 0.013. So I'm going to make it just go by 1, 0.1, 0.2, 0.3, and I'm definitely not going to have room going at this 0.5. So what was this probability of ordering a French entree given French music? French was 0.52. Correct? So we're going to draw a bar graph going up to 0.52. So what is this? This is your proportion on here. Not the count, but the proportion. So then Italian, what's the probability of ordering French given Italian? Was 0.537. So this is where also I would go ahead and pause this video and try to create your own and do the same thing here. You're going to put the same music choices and scale them and see if you can see if there's any correlation. None was 0.357. Okay, Italian. Try to make sure those are the same. So again, our music choices was either French, Italian, or none. I'm going to try to scale it the same so I can see any correlations. And what was the probability of ordering Italian given French? Was 0.013. What about ordering Italian given Italian? It was 0.226. And the probability of ordering Italian given no music was 0.131. Okay, one more. We got to do ordering an other entree based on French, Italian, or none. So what's probably of ordering an other entree given they played French music? Was 0.467. Oh wait, I gotta scale this first. So it was what? 0.467.